Okay, so this worksheet, at the top it says, actually I hand wrote a different title on it, but anyway, this is another word problem worksheet. Before I get started, this year we are not going to go through number 6 or 7, so you can go ahead and just skip those for now. But that is only on the worksheet that starts out with number 1 talking about hitting a golf ball off the ground. All right, so let me go through number 1. All of these are similar. Number 1, you hit a golf ball off the ground, and the ball is following a parabolic path, reaches a maximum height of 4 feet. This word right here, max, should stand out. We'll come back to that in a moment. It should say it hits the ground after a total of 10 seconds. What is the equation of the parabolic path the ball traveled through? So I'm going to go use the information that I just read and kind of draw a graph. So we're going to start with not the best line drawer. There we go. So the ball is being hit from the ground. So I know that it's going to start on the ground. And I'm choosing to have it start at 0, 0, because that's going to be the easiest for me to find the equation. And let's see, the length along the x-axis, the numbers that we're going to put along the x-axis is going to be time. And it talks about it being in seconds in the word problem up there. And then the height in feet for the y-axis. It says it starts on the ground and then it hits the ground after 10 total seconds. So it's going to come back down and hit the ground after 10 total seconds. All right, and it's following a parabolic path, has a max height of 4 feet. So the highest it goes is 4 feet. That word max tells me that we're talking about the vertex. And the max height of 4 feet, that's the y value of the vertex. The x value, when it starts, the x value and the y value is 0. So we have an x intercept and a y intercept right there at 0, 0. Comes all the way up, hits a height of 4, then it lands again on the ground at 10 seconds. So that's going to be my x value, and my y value will be 0 at those 10 seconds. Knowing the two x-intercepts is going to help me find the rest of my vertex. The middle, the axis of symmetry, will be when y is 5. X is 5. So when x is 5, we have our vertex 5, 4. Now we have to find the equation. If we know the vertex, and a point, we're going to use vertex form. If we know the x-intercepts and a point, we're going to use factored form, or otherwise known as intercept form. In this case, I have both the x-intercepts and the vertex. So this is where you can actually choose which one you would like to do. So what I'm going to do is I'm going to do both, but you will get to choose which one you like better. However, some of these you will not get to choose. So if you can't find the vertex and the x-intercepts, and I did that on purpose. Some of these only give you the x-intercepts or only give you the vertex. If that happens, then you need to do it by that form only. Checking your answers is going to give you an idea if you've done it correctly. So let's say that we are going to do this one by vertex form. First of all, you have to know the vertex form. You can't um, take a quiz or a test when you don't know the material that you're supposed to know. So we have to absolutely know the vertex form. And I just wrote down the formula. So when we know the vertex form, we're going to first plug in the vertex. And I'll just do it in a different color, minus 5 squared plus 4. So that's my first step. By the way, this is totally review of stuff that we've learned before. We've already taken a quiz on it. We're just adding it into a word problem. So the next thing we're going to do is we're going to have to pick a point, and it does not matter which point we pick. Besides the vertex, I have 2 points. So I'm going to use the point 0, 0 because I think that might be easier. And x and y are both 0, so I will put in the y spot 0 and in the x spot 0. Everything that is black was from the original equation, and then minus 5 plus 4, that's our vertex. And so 0, 0 is the new point. So once we get here, we are going to simplify using PEMDAS. And when we're simplifying, we just do the normal order for PEMDAS. So I'm going to have 0 equals, we need to do parentheses first. So I get negative 5 squared plus 4. After parentheses is exponents. So 0 equals negative 5 squared is 25 plus 4. Now I'm going to do multiplication or division. And that gives me 25a plus 4. And at this point, I cannot do adding, subtracting because these are not like terms. So now I'm going to solve by doing PEMDAS backwards. So over here, we're going to take away 4. So that's adding, subtracting. And then I'm going to divide by 25. And I have a equals negative 4 over 25. So that's our a value. If you can reduce 4 over 25, then you need to reduce it. I can't, but some of these questions you might have to reduce the fraction. You always want to check. So then finally, what we do is we go way back up to the very first step where we put our vertex in, and we're going to add in that a value. I'm just going to rewrite it. F of x equals negative 4/25 x minus 5 squared plus 4. Okay, so that is the answer in vertex form. But you could have done it in factored form. And some of these down below, you will only be able to do in factored form. So I'm going to go over that one too. Again, I've taught it before. This is total review. Just added in a word problem. That's the only difference. So factored form is f of x equals a, and then we do parenthesis x minus p and x minus q. Our x-intercepts are 0 and 10, so I'm going to put those in the spots of the p and the q. So I'm going to have f of x equals a, x minus 0, x minus 10. And anytime I have x minus 0, I don't need the x minus 0, I just need the x. So I'm just going to simplify that a teeny tiny bit. So this is our equation so far. Now we have to pick a point. And the point that I'm going to choose for this one is not the x-intercepts. So the only other point I have is that vertex 5, 4. I'm going to plug in the vertex 5, 4 wherever I see the x and the y. So remember, f of x is y, so that's the 4. My x value is 5. Oops, sorry. Forgot I was trying to keep everything colored. Here we go. So my x-intercepts are blue. Oops. Oh, no, 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 no. Try that again. The vertex 4, 5, the x and the y, those are in pink. And then the original, the a, is in black. I now have to solve for a. And we're going to do the same thing we did over here. We're going to first simplify. And that's PEMDAS forwards. So let's see, parenthesis, we've got 4 minus 10. I've totally messed this up. Okay, my x value is 5 and my y value is 4. I don't know what happened there. I apologize. Okay, let's do PEMDAS. We do our parenthesis. That gives us -5. Then we're going to do exponents. There aren't any. We're going to do multiplication division. And there's a few multiplication steps. So over here, I'm going to multiply the 5 and the -5 and multiply that by a. So I get -25a. So I use multiplication. And then from there, there's no more to do, and it's simplified. So now we have to solve by doing PEMDAS backwards. I look for adding and subtracting. There aren't any. Look for multiplication division. We can divide by -25. And I get -4 over 25. That's the exact same a value that we got doing the other method, and that should always be the case. The a value, no matter what form you're putting it in, should always be the same. So we're almost done. We need to go back to this first step. Actually, it's the one I simplified, where you put in the x-intercepts at the beginning, and we're going to put the a value in. So to finish this one, I'm going to have f of x equals our a value, -4 over 25, and then x parenthesis x minus 10. So that is the factored form for question number 1. When you do this, if you have the option for doing either or, then it doesn't matter which one you do. I will have both answers. But like I said, for some of these, you can only do it one way. All right, there is one more thing I want to talk about. It is number 5. Just because skateboarding half pipe, some people don't know what that is. So I just wanted to show you what that looks like. And I found a picture of a skateboard half pipe. So it's got that parabolic shape right there. There has to be a place for people to stand before they go down. And then that same place to stand, that's on the other side as well. So that's what a half pipe looks like. So if we're reading this one, it's designed so that 2 feet from the start, the pipe drops down below to a minimum of 10 feet below the surface. And then the skateboarder will come back up to the surface again after 8 feet from the start. So it's talking about from the start. That means that I'm going to have a start and 2 feet from the start. That's when it goes down. And then 8 feet from the start. So the start's here at 0. 8 feet from the start. That's when it comes back to the surface. So here I'm going to put it in some color so maybe you can see it a little bit better. But that's the shape of the half pipe. All right, where 2 is right here and 8 is right there. It does say that goes to a minimum of 10 feet below the surface. When we talk about mins, we're talking about vertex. And so if it's 10 feet below the surface, that's going to be at a negative value. So there's a little hint on number 5. Make sure you also do number 8. Number 8 is just a complete review over graphing, and we need to make sure that we know that this is vertex form and you are graphing from using transformations. Okay, and that's it. Thanks.